Hello students, in this video we will learn the classification of functions. Okay, so let's start. First one is one functions, which is also known as injective mapping. So let me explain you what is one function. Write it down. Let f be a function, okay, from a to b. How will you write from a to b? F is a function from a to b. Okay, so what is the condition for one function? If different elements of a have different f image in B. Okay, so if different element of set A have different f image in B, then the function is called one function. Let me explain you through the diagram. This is called mapping. Okay, here you have got a set A and this is another one, B. F is a function from A to B, so you will draw a arrow from A to B. Now suppose here in set A you have got A, B, C. Here 1, 2, 3. So what does this statement say? If different element of A, okay, have different f image in B, suppose A is going to 1, B have got image 2 and C have got image 3. Okay, you can also make A goes to 2, B goes to 1, or C goes to 3, like that. So different element in set A have different f image in set B, isn't it? So this is 1 okay, 1 1. Look at other example. Suppose there is a set A and here you have got set B. This is A, this is B, and f is going from A to B. A, B, C, 1, 2, 3. Okay, suppose A have f image equal to 1 and B have f image equals to 2 and C also have f image equals to 2. So is this a one function? No, right? Because different element of A does not have different f image. Since B and C have got same f image, that is 2, so this is not a one function. Not one function. Okay, this is not one function. Let me give you one more when mapping example so that you will be clear. Let me clear this first. Look here. Suppose you have got set A here. Hold on. Set A, and here you have got another set B. A, B, and f is a function from A to B. So you will make arrow from A to B. See here. Let me take black ink. A, B, C. Here you have got 1, 2, 3, 4. A have got f image 1, B have also got f image 2, and C have got f image 3. Here left in the set B there is left one element, that is 4. So is this 1 function? Is this 1 function? Yes, because different element in set A have different f image, right? So this is also a 1 function. Okay, you can understand this 1 function with the help of graph also. Okay, see, one more condition you can apply. F of x1 is equal to f of x2 if and only if x1 is equal to x2, isn't it? Because suppose I'm giving you a general diagram. Okay, look here. Suppose there is a function like this. Here you have got x1 and here you have got x2. So your f of x1 and f of x2 will be here, right? Isn't it? Let me make it clear. Okay, here you will have f of x1 and here you will have f of x2. Okay, both f of x1 and f of x2 are equal. What does this mean? Here in input you have got x1 and x2, and f is a function such that when you put f of x1 you get one output, and when you put f of x2 you get the other one. Both are same. So is this 1 function? No, right? So in order to be 1 function, x1 must be equal to x2. When this x2 comes close to x1 or it overlap x1, then you can say that it is a 1 function. So this condition is necessary. Okay, when f of x1 equals to f of x2, you will have to prove x1 is equal to x2, then only you can say that this is a 1 function. Because if x1 is not equals to x2, you will get the same output, isn't it, at two different input. So this will be not a 1 function. Okay, for example you can write, suppose f of x is x plus 1. Okay, so you need f of x. Suppose we write f of x1 equals to f of x2. and you prove that x1 equals to x2, then we can say that this function is a 1 function. What will be f of x1? It is x1 plus 1 equals to x2 plus 1. 1 gets cancelled out. x1 is equal to x2, isn't it? You got x1 equals to x2. So this is a 1 function. Okay, the function given f of x1, f of x equals to x plus 1 is a 1 function. Okay, now we will see many one function. Okay, injective, right? Many one function, write it down. The second one is, hold on, many one function. We can also say not injective. Okay, 1 function we used to call by other name injective function, injective mapping. Here many one function is not injective. Okay, you can write in the bracket not injective. Got it? So let us understand. Okay, let f is a function from a to b. What is the condition? If two elements of a have the same f image in B, okay, then we can say that it is many one function. Suppose x1 and x2 both belongs to set A, and here f of x1 is equal to f of x2, but x1 is not equals to x2, then we can say that this is many one function. In the previous function, 1 function, x1 was equal to x2. Why? Because if x1 is not equal to x2, then at different output you are getting, then at different input you are getting the same output, which is many one function. Let us understand this through mapping. Okay, let us draw it. This is set A and this is set B. Okay, here write A and B. F is a function from A to B. A, B, C, 1, 2, 3. Suppose A has got the F image 1, okay, and B and C have got the F image 2. So this is many one function. From B and C we can see many is going to only one output. So you can say this is many one. Okay, let me give you one more mapping. Suppose this is set A and this is set B. The first element goes here, okay, and second and third element goes to this. This is also 1 1 mapping, even though you don't have any remaining term in B. This will also be many one function. Okay, for example, let me explain you this with the help of an example. Okay, example, a very good example of many one function is sin x. As we all know, the graph of sin x is, it oscillates between +1 and -1. Okay, it oscillates between +1 and -1. Same goes negative side also. Okay, just I think here you have got 1. Okay, this level 1, and this is half. Okay, 1/2 in the y-axis. At what value of sine you get half? 30 degree, right? Pi/6. Again, half you will be getting at this point. This is your 5 pi/6. Means at two different input you are getting the same output. Okay, so at whenever at two different input, at different input you get the same output, it will be a many one function. This is nothing but same as see, at pi/6 you have got output half, isn't it? And at 5 pi/6, let me make it clear. Pi/6 you have got output half. Okay, and at 5 pi/6, that is 150, again you have got output half. So this is many one function. Okay, I hope you are getting what I am trying to say.